Hello class, let's take a look at this problem here. We have 944 babies born to parents using the new method. We have two different methods for conceiving a girl, and 868 of 944 babies, 868 were girls. Alpha is 0.05. We want to test the claim that the new method is effective in increasing the likelihood that the baby will be a girl. Identify the null hypothesis, the alternative hypothesis, Okay, so clearly looks like you had looks like the statement is set up correctly. Indeed, it should be this. And again, we know that when we have a child, it's either going to be a boy or a girl. So there's a 50-50 chance that it's going to be one gender versus the other gender. And we're talking about a baby girl, and we want to increase the likelihood of a baby girl. So that means the alternative must be greater than 0.5. This is a one-tail test. Okay, so specifically, this is actually going to be a proportion test because they tell me an n value and then they give me an x value. In this case, 868, the number of successes out of the total number offered. So let's go ahead and use StatCrunch to find this. Go to Stat, Proportion Stat, one sample with summary. The number of successes is 868. The number of observations is 944. And make sure to change this to greater than. As you can see, by default, it sets for 0.5. But always make sure to double check this area, and most certainly double check the argument in the alternative statement just to make sure. Hit compute, and here is my z-stat. So you can see the z-stat is huge, and therefore the corresponding p-value is going to be extremely small. Okay, and these numbers kind of jive with what you have, right? Okay, if there's a 50-50 chance you're going to get a boy and a girl, and you have 944, then assuming 50%, we would expect to see around 472 girls and 472 boys, given 50-50. Okay, but as you can see here, we had a substantially greater number of girls. So that means that we would expect this to be very big, and likewise this to be very, very small, okay, as a result. So all these numbers really kind of sync with each other. So since p-value is very, very small, i.e. smaller than 0.05, we will reject the null hypothesis, okay? And therefore there is sufficient evidence to support the claim. And it turns out there's actually very, very strong, compelling evidence to support the claim because the p-value is so very small. Thank you.